Scenario. The graph shows the position x as a function of time for the center of mass of a system of particles with a total mass of 5.0 kilograms. An external force exerts on the objects in the system for 0 to 4 seconds. Question. What is the particle's initial momentum from 0 to 2 seconds? The answer. Well, let's take a look at the equation for it. The initial momentum P is equal to the mass times the initial velocity. The mass here is 5 and the initial momentum V naught is 5 meters. How are they getting it? Well, for the first 2 seconds, it goes from 0 to 2 seconds. The total distance traveled was 10. 10 divided by 2 is 5. Okay, or you can actually determine the slope here. You should get 5 meters per second. That is how I get the velocity here. So multiplying it, you get the first part, which is the 0 to 2 seconds. The initial momentum is 25 kilograms times meter seconds. Next question. What is the particle's momentum, which is the final momentum from the 0 to 4 seconds? From 2 to 4 seconds, we can do P1, which is the next momentum. We can consider that the final momentum is equal to the mass times the velocity. Same equation. The mass is 5, but let's look at the new velocity here. How am I getting this negative 2.5? Well, just figure out the slope. You can treat this as a point, and you could treat this as a point. And this is 5.5. Okay, if you figure out the slope here, it should get you the value of negative 2.5. Once you multiply, you should get it equal to negative 12.5 kilograms times meter second, which is going to represent the momentum final here. Next question. What is the resulting change in momentum from 0 to 4 seconds? So we can combine the first scenario and the second scenario, but we're looking for the change. So the change is actually the final minus the initial. So delta P is equal to P1, which is the final, minus P naught, which is the initial. So you have the final, which is negative 12.5, and the initial was 25. So you subtract 25. You should get the value negative 37.5 kilograms times meter second. So the question finally asks, why is the resulting change in momentum here a negative value? Well, take a look at the graph. Well, if you take and describe the scenario, the object was moving and gaining distance. Then all of a sudden, after 2 seconds, the distance decreased. So the object's coming back. The only way the object can come back is that if the force is pushing back against it. So if the object was going right, for it to get a negative distance, it has to go left. That means the force has to be applying it to the left. So that negative means that the change in momentum is in the opposite direction of that external force. That is the only reason the object can now come move left. There you go.